Let's do an example of expanding logs first. So I'm going to expand these two logarithms, and my advice is, well, I have a couple pieces of advice. First, be vigilant that you're not inventing your own logarithm rules. I see a lot of students that do steps such as the following. They say logarithm of a plus x, let's make that y. Logarithm of y plus x is equal to log of y plus log of x. There's no rule like this. There's just not. There's the three logarithm rules that we have at the very beginning, and that's it. And there's no rule for log of one thing plus another thing. So don't make up your own logarithm rules. And when you start, apply your logarithm rules step by step. So in this first example, we have that this would be, well, I have log of one thing divided by log of another thing. So I can write that as log of the numerator minus log of the denominator. And now you might be tempted to take this square and drop it down because we said we could drop down exponents. But that would be incorrect because in order for you to drop down the exponent, everything in here would have to be squared. Okay, so we can't do that. This 10, however, can drop down because everything in the logarithm is raised to the 10th power. So this can drop down. That's using logarithm rule 3. And this first logarithm is the logarithm of multiplication of two things, which means we can use logarithm rule 1, which says this will be ln of 3 plus ln x squared minus 10 ln x plus 3. Finally, now in this second logarithm that I have written, everything in the logarithm is squared, so this can fall down, and we're just left with ln of 3 plus 2 ln x minus 10 ln x plus 3. And do not be tempted to do something with this ln of x plus 3. There's no rule that says ln of one thing plus another thing is equal to something. So this would be our final answer. We're done with the first problem. Let's go on to the second one here, which is logarithm of the sixth root of x squared plus 9. Now, if you're confused about the root, remember that we can express roots as fractions. Let's go ahead and give us some more room here, give ourselves some more room. So the logarithm in the second problem is equal to x squared plus, what was it again, plus 9 raised to the 1/6 power. That's what I mean by you can express roots as fractional exponents. And so now the 1/6 drops down. We get ln 1/6 ln x squared plus 9. And you might be tempted to take this further. However, there's nothing you can do with this x squared plus 9. Now if, and this is not true, but if it happened to be something that factored, so x squared minus 9, let's just suppose that for a second, then we would be able to continue and write that this is equal to ln of, I can factor x squared minus 9, and now I have ln of the multiplication of two things. This becomes 1/6 ln x minus 3 plus ln x plus 3. So only if it was a minus sign here can you do this. The reason you can't do it if there's a plus sign is because x squared plus 9 does not factor. Okay, it's not equal to x plus something else. And if you're tempted to put 3 here, you might want to check that. When you go to do x plus 3 squared, that's not x squared plus 9, because, well, when you FOIL this out, you get x squared plus 6x plus 9. Okay, let's do an example combining logarithms. So I have 4 ln 2 minus 3 ln x minus 1 half ln of x plus 4. And again, I advise you take this in as small as steps as you need to. So first I'm going to take this 4 and I'm going to move it upstairs in the logarithm, so I get ln of 2 to the 4th. Then minus, this 3 can do the exact same thing, ln x cubed. And finally, this 1 half as well can be ln of x plus 4 to the 1 half. Now there are a couple different ways you can go about doing this next step, but what is important is, well, we'll talk about that in just a moment. So I'm going to take this step by step. First, I'm going to do this operation here. ln of one thing minus ln of another. That is ln of the difference. So this is ln of 2 to the 4th over x cubed. And then I'm doing minus ln of x plus 4 to the 1 half. Now I'm doing ln of one thing minus ln of another. Let's put some equal signs here. And so this will be ln of the first entry, which would be 2 to the 4th divided by x cubed, all divided by what's in the second logarithm, which is x plus 4th to the 1 half. Now inside the logarithm here, there's some simplification to be done. If you take a fraction and divide it by another fraction, which is what this is, it's this fraction divided by this fraction, then that is the same thing as taking the numerator, the fraction in the numerator, and multiplying it by the reciprocal of the denominator. And so this logarithm is going to be equal to, well, it looks like the x cubed and x plus 4 to the 1 half needs to be in the denominator. So this is ln of, let's give myself some room, 2 to the 4th divided by, what was down there, x cubed. And the other term was x plus 4 to the 1 half, which I think I'll write as the square root of x plus 4.